Hello, and welcome to this eSchool News webcast. My name is Andrew Barber. I'm a senior contributing editor here at eSchool News, and I'll be acting as the moderator for today's presentation, which is sponsored by Stratasys. It's titled, How to Combine the Old and the New via 3D Printing. And we'll look at how 3D printing works and how teachers can use these new digital fabrication tools to support and enhance learning. Now, before I introduce our guest speakers, I want to take a few moments to highlight a couple of items. First, today's event will be recorded, so you don't have to worry about taking notes. In a couple of days, we'll send out an email to you that will contain a link to the recorded event, and you'll also be able to download a PDF of the presentation from that same email. And second, please ask questions. Don't feel as if you have to wait until the end. At any time during the presentation, if you have a question, just type it into the Q&A console and hit the submit button. I hope we'll have some time at the end, maybe 15, maybe 20 minutes at the end when our speakers can answer your questions. And we also have a chat function which can be launched via the brown group chat icon, which is at the bottom of your screen. Now please use the chat to talk among yourselves or to contact me or the eSchool News team with any technical issues or other concerns that you may have. However, I'd ask you please not to use the chat function to ask our speakers questions. They're simply not going to have time to monitor the chat. If you want to ask a question, please use the Q&A panel instead. And with that out of the way, let me formally introduce our speakers. Stefania is the founder of Academia, a global network that designs workshops and kits enabling kids to use curiosity, play, and empathy to solve global challenges. She's a former Google employee and one-time education teaching fellow at Singularity University. This August, she starts as an MIT Media Lab graduate student in the lifelong kindergarten group. Our second speaker is Jesse Reutenberg, and Jesse has been the head of education for Stratasys for the past 4 years. He has a BA from the University of Minnesota and is a former science teacher. He's been involved in 3D printing, additive manufacturing, and direct digital manufacturing for the past 7 years. Welcome, Stefania, Jesse. It's a real pleasure to have you here today. Stefania, why don't you get us started?
Thank you, Andrew. Good afternoon, everyone. I'm going to start talking about different applications of 3D printing in education. But before we talk about that, I wanted to walk you through a short definition and history of 3D printing. What is 3D printing? 3D printing is the process in which we are creating 3D solid objects by using an additive process. This additive process consists of successive laying down of layers of material, which can be, we could use many different types of materials and many different types of plastics. We tend to believe that 3D printing is a very new technology and it's very much associated with the growth of maker movement in education, but actually it was first invented all the way in 1983 by Charles Hull. He invented what we call stereolithography, which is the process of taking digital data and transforming it into a tangible solid object. This technology was made public in 1988, and the first 3D printers were used in 1996. Actually, the first 3D printer prototypes were called standard prototypes, which later became SolidScape. To this day and age, the way 3D printing works consists of the following steps. The first thing we do is that we create a design using CAD or any other modeling software. Then we send this design to a 3D printer in STL format. STL comes from stereolithography, like the original concept invented by Hull. Then we choose the material. Like I said, we could use many different materials: plastic, paper, rubber, metal, the chocolate. And then this filament material is fed to the print head of our 3D printer. This printer head is warming up and it will melt the filament slowly. As the material is being melted, it is being sprayed and squeezed layer by layer. The advantages of using 3D printing is that it revolutionizes manufacturing the way we imagined it, and it enables individuals to create their own products. The other advantage is that we could use many different types of materials, and that the plastics that are being used can be recycled. It also has applications in all industries, like health and medicine for producing different hearing aids or prosthetic legs, for example, or even skin grafts. And it's very interesting to see many cases of health applications that were used, especially when there was no other solution, so like a 3D printing skull. Other applications consist of prototyping faster and more accurate models, for example, in architecture or landscape design. In manufacturing, we saw an explosion of companies and applications for absolutely everything from musical instruments to bikes. And last week, there was a Kickstarter campaign that transformed even a phone into a 3D printer by using the DLP technique. Okay, you're going to say, this is really nice. We can use 3D printing in fashion and retail. We can use it in manufacturing. We can even use it in space. There's this company from Silicon Valley called Made in Space that managed to send the first 3D printer to the International Space Station to create customized parts. But how do we use 3D printing in the classroom? Well, in the classroom, we have many different applications of this technology, and it's multidisciplinary, and it could be used in many different scenarios. This technology is already being used in a lot of classes around the United States, and from primary schools to high schools, we see many teachers using 3D printers. Why is it important to use 3D printing in education? It enables us to create more accurate and realistic models for science classes. It also enables us to do faster models, especially in degrees in engineering, architecture, or art. Last but not least, using 3D printers is allowing our students to imagine many different things and play with many different materials. I wanted to show you a couple of concrete examples of how you could use this technology in your classroom. The first example is the Beetle Blocks case study. Beetle Blocks is an application of a wider frame for visual programming called Scratch, and it's adapted especially for 3D printing. What you can see on the left-hand side is a scenario of instructions that the kids could assemble in order to generate the shape that we see on the right-hand side and the settings that will be sent to the 3D printer. This is actually very good to start when using 3D printing for the first time, because it doesn't require to be used to more complex 3D modeling software like CAD. And because it's visual, we can just drag and drop the different blocks, and we can see in real time what is happening based on our settings. So in this case, you can see I was trying to do a seashell, and in the set of instructions, what you and your students can do is to play with all the different settings, like how much would you like your extruder to change, how many times do you want to repeat the movement, how many times do you want to rotate your shape. And this is actually like available for free online. And I created an example of curriculum that you can see on the slides. You have the link. And what's nice about this Beetle Blocks is that it's using a visual programming environment that kids are already used to, which is Scratch. It's very, very easy to share and modify existing shapes. And it starts like with simple scenarios, just dragging and dropping like different shapes and changing and customizing the settings for the 3D printing, for the 3D printer. But it enables self-expression for your students. They can take it as far as they want. Another example of how Beetle Blocks was adapted and used in the classroom is this example from the Exploratorium, the Tinkering Studio, where they actually used the Beetle Block software to create designs for a watercolor bot. Because they didn't have a 3D printer, they realized that they could use the same software and the same settings to actually make watercolor drawings. And they were able to use, for example, mathematical equations and fractals to generate like very complex shapes. So I think this is a very creative way to show how we could combine the new technology of generating these 3D designs and instructions with the old school activity of watercoloring. The other example that I really like is this professor, Vince Rossi, that has used 3D printing to actually recreate a T-Rex skull. So this is really a great example to show that 3D printing can enable us to do things that we could not do before. Unfortunately, kids today do not have access to T-Rex skulls, and maybe they can find them sometimes in some museums, but they cannot play with them, they cannot touch it, they cannot have a feeling for the shape and the dimensions of the T-Rex skull. So this professor had the idea to recreate the model by scanning a museum version and then 3D print it in the classroom. It turns out that this model was actually made available on Thingiverse. So if you want to use a T-Rex skull in your biology class, you can actually download it and 3D print it. And it inspired many other museums, like the Smithsonian Museum, to create a whole exhibition of 3D printing replicas of most of their models. And yeah, I think there are many other examples of how this technology can be used in the classroom. I would like to stop here in case you want to write down some questions or explore the links I shared and the resources. And I will pass it on to Jessie to tell us a bit more about learning by making and Stratasys.
Thank you, Stefania. Great presentation. As Andrew said, I've been engaged in 3D printing for almost a decade, and the most exciting part is absolutely when instructors and students start to make 3D printing part of their classroom and their curriculum. I'm with Stratasys, and I'm going to talk more intensely about how Stratasys is changing from being a 3D printer company just making 3D printers to modifying or transforming to a company that's focused on 3D printing solutions, and specifically these solutions in the educational world. So I'll start with education today. And education today we see the run-of-the-mill or all types of ways that 3D printers are being used in a classroom, from focusing on printing student design to teaching tools or instructing tools created by teachers to help prove out a principle or teach maybe an abstract thought or idea. So the job market today is much different than what it was in the past and with past generations. The skills and abilities that employers are looking for are different as well. You know, we're a company that manufactures 3D printers. We definitely are engaged with a lot of these industry partners that are looking for a different skill set in a workforce. The skills are working in groups. It's the skills of creative thinking, the skills of problem solving with a set of tools. We truly believe that 3D printers engage in that type of learning if used to their fullest extent in the classroom. The term STEM, or we're hearing it more and more, STEAM now, adding the arts to this equation, it's not going away. When we were first hearing it 7 to 10 years ago, we didn't know if it was going to be a fad or just a buzzword. But every year we hear more and more STEM jobs are on the rise. More and more companies are enticed by those skills and capabilities of a STEM-focused student. There are more and more engineers retiring from the companies out there. And for a while there, the United States was producing 10-to-1 lawyers to engineers, while other countries like China and India were doing the opposite, producing 10-to-1 engineers to lawyers. I think the school systems and the governments, the state and federal, have put a strong emphasis on increasing what we're doing in the STEM fields. Salaries are higher, so students naturally will be drawn to that. But I think a lot of students were shying away from the STEM careers because they had a bad experience in a math class or a science class. We need to change that. And one of the key areas of change that we've seen is enticing or introducing students at an early age. There's no reason not to introduce students to STEM in preschool and in kindergarten, so they can actually experience and have engagement with some of these sometimes abstract thoughts. But people that are introduced at that younger age are better innovators. They're inventors. They're confident. Project-based learning, another area that is totally transforming in the educational world. The fact that people are actually doing something, not just reading about it in a book, finding some bold words, and then filling out a Scantron test. It's going through the lecture, learning what you need to do, but then applying it. I always go back to experiences that I've had in physics, and when something fails, I didn't get to go back and reiterate. I didn't get to go back and learn why my first inclination was wrong. Project-based learning, that's what it's all about. I'm in Minnesota, and we have more varsity robotics teams than we do men's high school hockey teams. That's extremely impactful. yes, varsity robotics. Robotics is a varsity sport in Minnesota, and it is extremely popular. And I've seen what this type of project-based learning, project-based competition does for confidence for those students that are often the shyer or more introverted types out there. So that STEAM factor is not going away, and we feel our product fits. It goes hand in hand with STEAM. And you're not going to teach a class on 3D printing, but you're going to enhance a classroom and a curriculum with a 3D printer. What types of teaching and learning will develop these skills? Things are changing, and that's why we're seeing it on all levels. Even the university level groups are starting to engage more and have less theory, or added on to the theory the project-based learning. So it's not just at that lower level. They're engaging in different ways of teaching. The traditional look of a classroom is changing. If you see the screen, people don't learn this way anymore. If you've been into classrooms lately, you're starting to see small tables, small groups working facing each other, because group work is so much more of a focal point these days than it was in the past. We're not about training students to work in an assembly line factory, okay? And that's kind of the way it was in the past, or to work, be an international type of student because this is the way everybody learned. It doesn't work that way. Companies are different. At my job, I've never taken one Scantron test, and in meetings, we typically don't sit classroom style. They're more collaborative. And so education is following suit. And it's about time. It truly is. What we see the most effective way to teach students is give them real-life problems. Give them something to solve that actually impacts who they are and what they do on a day-to-day basis. It's so much more powerful to understand something when it actually makes sense to you and your world. And we've seen people using the 3D printer in this way, whether it be making a custom prosthetic for a student in the school that is in need. We have a yearly competition. I'll kind of dig into that later. But one of our winners a couple of years ago, she built a jig to help one of her friends that had a hearing aid to use her iPod headphones. That's taking a real-world problem and applying areas of design and manufacturing and bringing it to life. That is a lesson the young lady that built that will never forget, due to the fact that it made an impact. It's something that now she can go and teach. This slide that's coming up, it speaks to the way people learn. And this is age old. This is Confucius had a quote about what he reads, he forgets. What he hears, he remembers. But what he does, he understands. And that's the same exact thing with most people that are out there in the world, and this is from students to executives. 90% of what you do, when you actually do it, you're going to remember that in 2 weeks versus 10% when you read it. I love the statistics of it because it makes sense. It's the way I kind of grew up and I lived. Doing stuff is the truly impactful part of learning. And beyond that, when I was a teacher, once you teach it, then you really really aren't going to forget it. We believe that 3D printing from Stratasys offers very rich opportunities to enhance skills. And it is STEAM skills and it's design skills, but it's also a lot of those soft skills, the creative thinking, the problem solving, the stuff that can't be tested unless you're actually testing on project-based learning. Being presented real-world challenges in a hands-on approach, that's something students don't forget, and they want to be a part of. And I'm very, very proud that our product actually engages in that and actually fosters that type of activity and that type of learning. A little bit about Stratasys. We are a 28-year-old 3D printing solutions company. Our founder, Scott Crump, invented FDM, which is fused deposition modeling, which is basically the heating up and the extruding of a filament through a nozzle. Our goal in life is to shape lives by revolutionizing the way things are made. And we truly believe we're doing that in all areas of life. Obviously in education, we're changing. We're a catalyst to be changing how education is done. We're in the medical fields, the dental fields, changing the way doctors are looking at problems, assisting with surgeries, bringing your MRI, your CT to life so you can sign off on a surgery or agree that that's the best route. In the automotive, aerospace world, streamlining products, we are bringing things faster to market at a faster pace, but also assisting with building better vehicles, assisting with building better planes because of the additive manufacturing. But none of that happens if design for additive manufacturing or design or CAD classes aren't taught at the middle school, high school, college, and university levels. The teachers out there that are teaching this stuff, the CAD classes, the design, that's the power. We deal with a lot of students that move on out of high school, college, or university. They go in and they impact a company, and they change the way a company works. We work with some very big automotive companies, and seeing some of the people out there that are impacting the changes to how products are manufactured or streamlining the processes, they're young engineers. They're young engineers that engaged in digital manufacturing since a very young age, and they go in and they change how companies interact. They make them better. And these students have the confidence to do it because guess what? They did it in school. They did it on the robotics team. They did it with their SAE challenge teams. And so it's the confidence building and the skills that these students graduate with is very impactful. And I do think we at Stratasys are truly engaging to make it an even more impactful opportunity. In education, we have an even, what I think, a stronger purpose to empower educators, to give them the tools that they need to allow these students to blossom. We focus on inspiring students. The fact that there are very important positions out there where those skills are needed, and the impact that these students can make on companies when they intern or graduate and work for these companies is obvious. And then we need to prepare these students to be the future, to grow our industry, and to shape lives with this applied learning through 3D printing. We really believe that it is a social duty of ours to empower these students, because they are going to change the world, and they're going to bring on the new products and invent and be the heads of these manufacturing facilities, or be a manufacturing engineer that's on the ground floor suggesting changes or creating jigs and fixtures to assist in the process. It's a very exciting time for us at this company. We do see 3D printing at every level of education, from the non-engineering K-12, where they are focused on arts and sciences, and we're starting to see history classes engage with the 3D printing design work, because the intertwining math, science, engineering, and history by doing design and presentation on wonders of the world or local buildings. It's not just engineering students that are using 3D printing, especially with the CAD programming and the apps that allow you to draw and paint and do whatever and then convert to a 3D image. Those are the students that we are engaging and inspiring to go further. The higher ed engineering in the K-12, it's about preparing these guys for their next steps as they build the confidence in these skills. In research, pure innovation, changing the way they do surgeries, changing the way things are created, research on materials and processes and software. We at Stratasys are truly engaging in some of these research areas and allowing some of these research facilities to go under the hood and see more of how we do what we do. And in industry, revolutionizing in the medical research, in the areas where 3D printing is actually touching human beings, from prosthetics to other medical applications. We really think 3D printing helps prepare designers and engineers for tomorrow. I was meeting with a group yesterday, and one of the people in there was a design student, and they talked about the importance of not just looking at a design on a computer screen in 2D, to have that 3D aspect, to have that touch, that feel. It's powerful. 5 years ago, we didn't hear that from designers. Now we're hearing it because they live in a digital world as well. Solutions in education. I'm just going to, Stefania had some phenomenal examples of solutions. I've got a couple just to showcase just ideas for learning that Stratasys has created and is in the process of creating. We do have a semester-long course. It's on our website, and it's free to download, and it's between 17 and 24 weeks of instruction with labs, rubrics, and files. The audience, it's geared for the college and university level, but we have a lot of high schools and middle schools downloading this because they want to take a section of it and bring that section into their course, and it doesn't have to be the entire course. But we've also seen colleges and universities running the entire curriculum and having great success. I think it was very well written. We have project-based learning modules. We worked with a current customer of ours who's had a 3D printer for 12 years, and he's created 8 modules, including a designer toolkit and the design toolkit is more focused for the instructor because it's got resources and tips and tricks on how to teach each of the lessons. But it ranges from a chess set, which is an advanced multi-week assignment, and I say it advanced in the CAD capabilities, to a beginner 2 to 3 day project creating an earbud holder. I don't know many middle school or high school students that don't have headphones, and so creating a custom earbud holder that fits their specific headphones is a real life thing that benefits from them. Every time I pull out my headphones, they're all twisted and tangled, and I've noticed now I have 3 different sets and they're all different, and they all have a different feel and different touch to it. So it is a real world experience to create something like that. Stratasys is the parent company of MakerBot, and MakerBot has put together what we call MakerBot in the classroom. Ideas, projects, activities, to put into your curriculum, neat ideas, and that's what we've seen that the community needs these days is more ideas and how to use the equipment, because we're seeing more and more non-engineering instructors have access or have 3D printing. And then we also have video lessons on our website. There are anything from building a catapult, a glider, to different riddles. They're interesting. They're not for everybody, but I think they're good, and they're thought-provoking. And I think everything that we've put together so far has the focus of that, is to bring more idea. We're not telling you it's the only way to do something. We're just saying, hey, here's an idea. Modify it if you want. Let us know how you're going to modify it. Moving beyond the classroom, we have student challenges. We have our Extreme Redesign Contest. This is our 10th or 12th year doing it this year, where we offer student scholarships to the winners. We are going to be announcing the winners, I think, in April for this year's challenge. We have Thingiversity's STEAM Challenge. We do have other corporate partner challenges, like GrabCAD has many different challenges that they offer each year, and it's for students. The key focus to that is competition drives innovation, and these students are very innovative and have come up with very good ideas, and we're trying to foster more of that through our competition. This is one of our customers' quotes. This is a customer in Ontario, Canada. He's actually a very thought-provoking dean at the local college, and he said this to us one day. He said, "Our labs are a playground for utilization. Because of that, students are opening doors to Fortune 100 companies like their refrigerators. The students come out with so many skills and so much confidence after engaging, and like I said, it's not just working with the 3D printer, it's doing the project-based learning, that hands-on learning, but engaging and learning and basically immersing themselves in an engineering and design language. It's just like a Spanish immersion. You really learn Spanish when you're when you are in it every day. The same thing goes with design and engineering. When you're doing it every single day, you don't forget it. We're here to inspire, engage, and prepare students to the future. Stratasys is a company that is heavily invested in education, from discounted equipment to education only, to materials that are discounted. We're continuing to build more and more scaffolding to assist the instructors out there. I think we have some time for questions, but from our standpoint, we are looking to partner with more and more educational institutions to impact how we inspire, engage, and grow the next generation. So, from my standpoint, I'm finished here. I think we're going to take questions, but I do want to thank Stefania for a great presentation as well.
All right, well, thank you so much, Jesse, and yes, thank you, Stefania, for a really interesting discussion about how schools can use 3D printing in the curriculum and as part of their general educational approach. We do have about a little under 20 minutes for questions. Now, I am aware that at some point, one of Stefania's slides came out of order, in which she was going to address some of the challenges and issues of bringing 3D printing into schools. And so, Stefania, why don't we use that as the very first question? Why don't you walk us through, and you have your slide up right now, I think, why don't you walk us through some of the challenges and issues that you've identified for schools who are looking to get into this space? Stefania, you have to, I think you may have muted yourself. You'll have to unmute yourself.
Sure. Thank you, Andrew. So I think there are quite a few challenges still. Can you hear me all right?
Yes.
Perfect. I think there are a couple of challenges at the moment. One, the main challenge, and I saw there were quite a few questions addressing this, is the cost. Especially if we want to use this technology in public schools, the current state of 3D printers is still challenging from a budget perspective. They are getting cheaper and cheaper, but they are still not affordable enough for allowing a public school to get a 3D printer in every classroom. The other challenge is sustainability. I said in my presentation that we could use different types of plastics and different types of materials like paper and metal. However, many of the PLAs, many of the materials we are using right now are not 100% recyclable. So I think there's a lot of research to be continued in this field to enable us to use materials that can be reused many, many times. And the third challenge, and I think this is quite crucial, especially when we talk about using it in the classroom, is the speed. When we are working with kids, we know that they are extremely impatient and they would like to have their design, their model be 3D printed immediately, if possible. However, 3D printing takes time. I know there's a lot of research right now with different technologies like DLP, which is basically exposing a liquid to light, and that is a bit faster than melting the plastic, but it still takes time. And I think that can trigger different solutions in the classroom. Like we could design something in 1 hour and then like print it and analyze the final results in the next class and so on. But it's definitely a factor to take into account. And I would say last but not least, I agree with what Jesse was saying about the fact that exposing and immersing young people in this kind of tinkering and prototyping environments is definitely preparing them for the future. But I think because we're talking about education and learning, we should not forget that the focus is on understanding key concepts. And this technology, like many other technologies, is just a tool. It's just enabling us to explain and create a lesson plan for very specific concepts that we're trying to teach. So we should not design lessons for the sake of technology. We should just use this technology as a tool to enable us in our work.
Terrific. Well, thank you very much. And I just want to ask a question that maybe both of you can take a crack at. Jesse, I'll start with you. That what you talked in your presentation about how people retain information, and that in 2 weeks you'll retain 90% of something that you do, but if you're reading it, it's 10%. Is there any research out there right now that supports 3D printing and how it can enable and improve learning outcomes? Is there anything out there right now that you can point to?
Right now, we don't have any reports completed. We're in the process of doing that. We do have a lot of anecdotal experience. The instances where an instructor tells me somebody actually understands concepts now, or how they've worked with underachieving students, and once they engaged with the design and the 3D printing, the student is putting more effort. It's a lot of effort, engagement, and building off that. We don't have improved test scores due to access to 3D printing yet, but we are working with a couple districts on building out that type of information. It's a great question, and outcomes is the key to everything, right? And when we can actually show them the report on how 3D printing, engagement with it, and hands-on learning has really impacted, then it's to me, then it's a no-brainer. You're going to see 3D printer in every potential classroom. Good question.
Okay. All right. Stefania, do you have anything to add to that?
No, I was looking at other questions that I wanted to answer, but I will let you walk us through that.
Okay. All right. Well, why don't we? You talked of Jesse had talked about a student course for, I think it was a college level course. Could you maybe, and Stefania, why don't you talk about this first? Talk about what age groups is 3D printing appropriate for? I mean, how young can kids be, and are there activities available for all these different age groups? Can you talk a little bit about that?
Sure. I've used 3D printers and different programs like Tinkercad or Beetle Blocks with kids from 7 years old and all the way to 16 and older. I think these type of projects and activities could be adapted for any age group, really. And what's really funny is that the younger the kids are, the more creative we have to be about how we make it accessible for them. For example, one activity that we did was to 3D print with pancakes. So we would have to create all the different parts of a plane and then assemble it, but it was made of pancake dough. That was a lot of fun. So I really think these activities can be adapted for any age group. I would say that the most challenging is the design in the different software, and there are different companies who are trying to provide now software like Tinkercad or 123Make or Beetle Blocks, or that are trying to provide environments where one doesn't necessarily need to learn how to use CAD in order to be able to use a 3D printer. And another practice that I see a lot, because there is this great repository which is Thingiverse, of other models that other people have built, it's much easier to combine and remix and customize existing models, and kids love to do that. So yeah, I would say it can be used with any age group, and it's all a matter of how much do we prepare it ahead of time for them, and what kind of activities we want to do.
Okay, thank you very much. One of the people in the audience says that they teach a psychology and sociology course at a community college. Is there a role for 3D printing in classes of that sort, and how are customers using them in disciplines like these? Stefania,
I can try to, yeah, I can try to answer that one. I actually know of some very interesting projects that were used in sociology classes. One of these projects is called the Love Project. It was done in Brazil. And basically what this group of designers and professors and students have done is that they combined 3D printing with sensors data. So they were using many different types of sensors to kind of read people's emotions. They ended up choosing three types: a sensor that was reading the brain activity, another sensor that was reading the heart rate, and a voice sensor. So by combining all these data while encouraging people to talk about their loved ones, they were able to generate like shapes and sculptures that would basically symbolize and give a tangible shape to their emotions. And yes, it's a very abstract and very artistic approach to interpreting and to discussing about our emotions. But nevertheless, I find it very interesting. And what I like about this project as well is that it shows something that I see a lot in the maker movement, which is combining many different ways of interacting with the world. Like we have all sorts of sensors and all sorts of actuators that are reacting to sound, light, touch, voice, and then we can choose how we want to interpret, analyze, and output all this information. And 3D printing it is a way of doing it. There are many other ways of doing it.
Okay. All right. Well, thank you very much. Jesse, let me come back to you. There are a lot of people in the audience who want to hear more about the curriculum, the training and the course that you developed. And so I'm going to try and push us back to the slide that you mentioned, which is the curriculum lessons, the semester-long course, and also the video lessons. Could you talk a little bit more about those and where people can find those courses and lessons and what they consist of?
Absolutely. Yeah, I'm glad people are keen to that because it's been a long time coming, and we've been asked by customers and partners for quite a while. We finally made a massive investment to do this. On our website, stratasys.com, we have a section focused on education. If you click on that education tab, one of the pieces that will come up is the curriculum. And let me just be very specific on where it is in that if people are on the website right now. So like I said, stratasys.com. Under our industries, there's a link called Education. Click on that, and it's the big banner in the front is our educational resources. So it's curriculum, project ideas, lesson guides, and then you can click to learn more. The key piece there, this is for the curriculum. To get to our educational modules, we have 2 of them out there that are launched to date, the earbud holder and the chess set. Those are focused on our GrabCAD website, but it's the same thing. We offer those in PDF file at no cost. I can post a link with you, Andrew, to return to everybody because it's kind of embedded within a press release right now.
Okay. Well, why don't we plan to have that? If you send us the link, we're going to be sending out this email in a couple of days with a link to the recording and allowing people to download the slides. Why don't we plan to include that link in that same email and give that information to everyone at the same time?
Absolutely, and I'll give all the links to the curriculum and content that we said, including MakerBot in the classroom and our inspirational videos. And then kind of a teaser, there's a lot more to come. We have a strong vision of content, and so a lot more is to come from Stratasys on that forefront.
Okay, great. And now this is a sort of related question, and I don't know, maybe both of you can tackle it. I know it sounds like Stratasys is developing a lot of material in this space. Someone is asking about specific sample lesson plans utilizing 3D printers in STEM, math, and science classes. Do either of you have any information about where they can get their hands on those?
Absolutely. So very soon we'll have more access to content like that at Stratasys. We've partnered with a school district, and they've done, they're basically a STEM corridor, and they're creating, curating their lesson plans on how this is being used from K to 12, math and science. They're a STEM corridor, and so even in their history classes, they have focused STEM encounters and moments where they talk about the impact, the science impact of something in a current event. So as that gets launched even closer, we'll fill in anybody that is aware. So just get on our database. But others that I've seen out there, go to that MakerBot in the classroom. There's a lot of STEM focused for K-12 activities.
Okay, great. All right, Stefania, maybe you can help us on this. Sorry to interrupt you.
Yeah, I wanted to add a resource there for these lesson plans for STEM. A great resource is stemcollaborative.org. They actually have many different resources for different subjects, math, science, for K2 grades, and then I find their collection very complete, and I've been using it a lot, so I would definitely recommend it, and I will share the link with everyone in the group chat.
Okay, great, thank you. Now we have someone who's asked the question from a perspective of history, and they're developing a digital public history program that they think this might be a very appropriate use for. But the question really pertains to faculty training, and how do they get more training for the faculty to help them develop not only the designs, but also the sort of integration into the curriculum that would be necessary. Do either of you have ideas on the faculty training side of this? How hard is it for faculty to do this, and where do they go to get more information about that? Jesse, do you want to start?
I would love to. So all of our equipment that we sell at the Stratasys level will come with installation and training, and that training is done by our Stratasys partners. We have partners that are across the globe, and specifically in North America, they focus on education. And so we have instructions on how to use the printer, how to print, how to change materials, that type of stuff. But this training goes beyond that, and it's more of how to integrate the product into your classroom. Like I said before, as we build out the content, that gets even stronger. But you do have local resources to do that, and we have quite the user base that is out there sharing what they're doing day to day. When it comes to the CAD instruction, that's typically the most difficult thing. But we're starting to see people use apps and other softwares like a Tinkercad or a Google SketchUp that are free, and they have really good instructional videos online of how to do it, let alone the opportunities to take classes or seminars in the summer to get more adept to using those CAD programs. The 3D printer, it's basically it's a hardware component that all you got to do is you got to build your information, send it to the printer. It's much like an inkjet printer when it comes to the use. Integrating it in the classroom takes a little more creativity, but we're building on that content.
All right. Well, we have actually used up the entire hour, so we're not going to be able to take any more questions. However, I do want to point out to everyone the group chat where Janice Budai and Stefania have put links. Janice has put up a link to the Stratasys lesson that so many people were asking about, and so there's the link if you want to go straight to that. And Stefania has also put up a whole bunch of different great URLs that you can explore further some of the answers she was providing during the Q&A section. So that is all the time we have left today. I really want to thank Stefania Druga and Jesse Reutenberg for excellent presentations, very, very good discussion. And I would also like to thank Stratasys for its support today. And that final reminder, we will be sending out that email to everyone who attended today with a recording of the webinar, plus with some of these links that we've been discussing in the last few minutes. So thanks all for attending, and this concludes today's webcast. Goodbye.